Hello Chemistry 2 students, this is video 2 for week 1 of our remote learning. So this video is about stoichiometry and the question, what is stoichiometry? Well, stoichiometry is the study of quantitative relationships between two or more chemicals, typically in whole number ratios, involved in chemical reactions. Well, that is a wordy sentence. Basically, what that means is stoichiometry allows us to predict the quantities, which means amounts, produced in chemical reactions, or it allows us to see how much of a reactant is needed in order to yield a specific amount of a product in a chemical reaction. Essentially, it's taking chemical reactions and studying the amounts of all of the different chemicals, the reactants and the products. So, if we're going to study stoichiometry, we have to take a look at chemical equations and why it's important to balance a chemical equation. Okay, balance is everything. In Chem 1, we learned how to balance the chemical equations, and we did this because of the law of conservation of mass. If we take the chemical reaction where you decompose water, which means to split apart water and turn it into hydrogen, H2, and oxygen, O2. If we do not balance the chemical equation, that would mean that on the reactant side we have 2 hydrogens and 1 oxygen. On the product side we'd have 2 hydrogens and 2 oxygens. Now that is a problem. Why? Well, because it would mean that we got an extra oxygen out of nowhere. And that is not possible because of the law of conservation of mass, which states that we cannot create or destroy mass. So we balance our chemical reaction, and the next bottom equation has 2 water molecules yield 2 hydrogen molecules plus 1 oxygen molecule. Now that makes it so that we have 4 hydrogens and 2 oxygens on the reactant side and 4 hydrogens and 2 oxygens on the product side. Now there is no problem there with the law of conservation of mass. So that is really important. Whenever we are dealing with stoichiometry, we must have a balanced chemical equation. Otherwise, the quantities between the reactants and the products is not going to be correct. So how do we take these balanced chemical equations and relate them to moles? So in Chemistry 1, we spoke a lot about chemical reactions and the law of conservation of mass and why that was important for atoms and molecules and things that were on this pretty small scale. Well, it ends up that balancing a chemical reaction also works with big numbers and large quantities. So while what we did is we said the equation 2H2O yields 2H2 plus O2 would mean that there are 2 H2O molecules decomposing into 2 H2 molecules and 1 O2 molecule. It also means, or it could mean, that you have 2 moles of H2O molecules decomposing into 2 moles of H2 molecules and 1 mole of O2 molecules. If we multiply the entire equation by basically the number that is a mole, it just means that we have a lot of molecules, and that we're having a mole of molecules. It would work the same way if we decided to do this with dozens or any other counting number, but in chemistry we are concerned with moles because that's what allows us to relate very large numbers of particles to life-size amounts of a substance. So the ratios of moles between reactants and products in balanced chemical equations are called mole ratios. So in this equation, the mole ratio between water, H2O, and hydrogen, H2, is a 2 to 2 mole ratio because there are 2 moles of H2O for every 2 moles of H2 in this equation. Now for hydrogen to oxygen, our mole ratio is 2 moles of H2 to 1 mole of O2. And again, that's just from the balanced chemical equation. That would be the mole ratio for H2 to O2. So using this, take a moment and tell me, and think about what the mole ratio would be for water, H2O, to oxygen, O2. Now, if you went to the balanced chemical equation and you said water has a 2 in front of it, so if I have 2 moles of H2O, and that's where I'm going to get the 2 for the mole ratios for water, and that oxygen has no number, which means 1. Therefore, I'm going to have a 1 for the oxygen. You'd be correct. And therefore, the mole ratio for water to O2 in this reaction is 2 moles H2O to 1 mole O2. Do not overthink this. It is very easy to overthink this and try to get fancy. The numbers for the mole ratios come directly from the balanced chemical reactions. So why is this important? Why is stoichiometry important? Well, remember back to the first day of Chem I, and I know this is true for my classes, but I believe that it's also true for Mr. Broadus's. I think what we both did in our classes this year is we took a copper coil and we put it inside a solution of silver nitrate. Now, a reaction occurs when you do this where the copper actually replaces the silver in the solution, and therefore the silver precipitates out and forms these beautiful crystals along the copper coil. And at the beginning of a class, the beaker looked like the one on the left in the image. And by the end of the class, the beaker looked like the one in the middle, and the next day it looked like the one on the right. So the stoichiometric question here would be how much silver was produced? And that would be really important if you owned a chemical plant specializing in extracting silver. You'd want to know the amounts. You'd want to know how much copper you need to put into the solution. You'd want to know how much silver is in the solution. And you would need to use stoichiometry in order to figure this out. Now, for all stoichiometry, this is what's really important, is moles are the key. You can figure out the quantitative, the amount, relationships between reactants and products if you convert to moles first and you go through moles through those mole ratios, you can figure it out. All right, that ends video 2. Video 3 is going to be about the mole-to-mole stoichiometry problems.